Hey guys. Hey Kevin. Can you hear me? Hey, just checking audio. Can you hear me, Kevin? Hello. Testing the audio. Are you able to hear me okay?
Yep.
Okay, good to know. Good to know that.
Yep.
How are you doing, Chris?
Doing well. How are you?
Pretty good. Pretty good. My question to you about the last session. The last session, which was the one on we did on halfway through on Netflix. The question is, how was it? It was different from all the previous sessions like we did before. Very different. So how do you find it in terms of feedback? That's what I'm looking to ask.
It's slower. Honestly, it's not as interesting for me, at least. I mean, I know it's something that I don't know. Honestly, I found the DevOps so far the most fascinating so far. I'll say
Okay,
that,
okay.
if
Good
that's
to,
fair.
good to know. Yeah. So I just wanted to check because that is something that is a different type of discussion. We discuss case versus
Sure.
a
Practice.
specific exercise. It's a different style and different type.
Yeah.
And that's why I wanted to ask. And I'll ask this when other people also come online. I think we
Sure.
have only Kevin right now, and even I think he's either muted or unable to hear. And not everybody is here right now yet.
No, I can hear.
Oh, okay. Good. So I would love to have some feedback on the last session. How was it? How different was it? Was it good, bad? Should we do more of this different types of cases, or should we do more exercises? I just want to know what the level of interest that you have from your perspective. I just want to get that perspective clear.
Right. I really enjoyed it. I'm not a programmer by nature, so I thought it was kind of funny because I found the DevOps to me was the least interesting.
Okay, the DevOps was the least interesting, I see, which
Yeah.
is a completely contrasting opposite perspective.
Right.
But
Because my background is complete. It's all infrastructure, storage, networking, firewalls,
right,
Windows, Linux administration.
right.
It's
Makes
just,
sense.
it's just a skill set that I've never had to get or maintain, really. I mean, a little PowerShell, and that's about it.
Okay, good to know. And so, from your perspective, the Netflix case study that we did the other day, 2 days ago, was it good or not good?
Yeah, yes, I really enjoyed it.
We enjoyed it. Okay, good to know. We'll do some more of it. We'll like to finish that exercise. We'll do a couple more cases, and then we'll do more hands-on in terms of infrastructure from a variety of cloud providers. We have these three guys here in perspective. So AWS, Google Cloud, and the Azure Cloud. So three cloud companies, how they have developed tooling to enable a variety of infrastructure, architecture, blueprints. How do you put things together? They have created some custom tooling, each of these companies have. And then we will also use a open source tool that kind of does it outside the cloud. You can actually do it in a Git repository. And so that is what this tool will help us to accomplish. So we'll go through that later. So here you basically write, plan, and construct infrastructure as code. And you focus on infrastructure, but you do it outside the cloud, as opposed to these guys, 1, 2, and 3. These guys will help you do it in their cloud. This is like an outside third-party tool. And more importantly, it is open source. And that's the one we will focus on to construct. And we have some exercises on this as well. So we'll do those exercises, but I just want to make sure that people are here and we don't have anybody else except two of you guys, which is strange. But maybe people are busy on a Friday. That's what it sounds like. or they just decide to do something else more interesting than this one, is what I suspect is going on. Or maybe they'll come online later on. But yeah, so let's begin. So what I'm doing is making sure that we complete that discussion that we had the other day, which was around this picture. And we were talking about, this idea of the types of auto scaling here versus here. It can be two different modes. This is using spot instances for processing pipeline, whereas this is using regular instances, or maybe reserved instances, depending on how much. Some reserved, some on-demand instances for upload machines that will allow either bots or people to provide those raw material that will come into the system that will eventually get here into the bucket. And once you put one of the items as a task item, as a to-do item in the bucket here, that it also goes and sits in this pile. And this pile will accumulate in this queue. So you have item number 1, item number 2, item number 3 will pop up and pile up as people will, or bots will include and bring on new content from what I call Hollywood, Bollywood, the sources that create those raw material for Netflix, for example. So that is what we discussed up until now. And we also discussed how this idea of spot instances, how it can disappear from your account. The machines can die on you. And if that happens, your halfway processing that may be going on, it eventually does not complete. So the work item that you may be working on, like item number 2, for example, in the pile, it may not finish. And before it actually halfway does, the machine seems to die because it was a spot instance. And so that portion of work is lost. But it's okay, you can do it again. In that case, this item number 2 does not actually get complete. So you have to get another box created. And when that box comes online, it will have to take that item number 2 again and begin processing from fresh. And eventually that processing will finish for item number 2. And so that processing, when it finishes, then you can mark the item number 2 as done. And when 2 is done, you only have 1 item. And eventually you will bring this queue down to 0, because that's what processing involves, is to finish processing all these incoming raw material. You want to process them. You want to keep the resulting file also here. And you want to finish the process and put the processed videos also in the bucket. So the bucket will have your raw files as well as processed output. And that output will sit here in these buckets so that it can be then streamed to the end customer, who is going to look for it, ask for it. So we'll finish off that exercise discussion around the end-to-end usage of this particular discussion that we're having. And so what I want to do is go back to our whiteboard. And before that, I want to just quickly check who is online. And so I think somebody else just popped up. And we have Chris. Hey, Chris. Chris has renamed himself from Office to Chris, apparently, which is nice. So I can see Chris is here. But again, most of the people are still enjoying a Friday, and I don't blame them. The weather is so beautiful outside. I feel like an idiot sitting inside, but don't worry. I was outside almost all day today and in the sun. So I just came in, into the building and started this session. So it's not regret. I still see the way, outside it is sunny, but don't blame other people who are not here right now, because the weather is fantastically beautiful, no doubt about it. So with that, let's continue our discussion around the topic of this company called Netflix as to how they actually implement that end-to-end pipe of delivering those raw videos. I think I need to grab my pen properly. So the raw video files that come from your sources. Sources can be Hollywood, Bollywood, Tollywood, all those people that make movies. And they will provide raw material that gets into the system and that needs to be processed. And that processing basically involves creation of a different format, not just raw that you get, but also a variety of target formats that you may need for your endpoint devices that you want to support. So these are the supported devices that you want to have enabled for your customers to be able to use, that you can use all these devices anytime you feel like and select any of the movies from the source listing here we have. And we seem to have a perpetually growing long tail collection. And that entire long tail collection is basically entire collection of movies that we keep are in some kind of a bucket in the Amazon cloud. Like you can see that here is that bucket storage here, media repository, is where the files are stored. The raw files are stored and the resulting output is also stored. For example, if you take an example of a movie, say, I'll just pick some name. So I'll take the name of a movie. We've been dealing with La La Land quite a bit, right? So let's say this file called La La Land .raw. That raw file that you receive is the input that you have. It includes audio and video both. So that will sit in that bucket right here. In addition to that, we will have a La La Land for iPhone and La La Land for iPad and La La Land for Windows PCs, and La La Land for Xbox, something like that. We'll have collection of different types of files that will become available at the end of the processing. In addition to these things, we will also have metadata about the movie, about the La La Land movie, right? What does this mean? It means something like this. You go here to La La Land, and you will find there is a place called IMDb. So if you go here, you will find a lot of data about the movie itself, not the movie here, but information about the movie that you can find it here apparently. And you can see that the movie has a name, it has a rating here, and that rating, it has duration, and it has the classification, the genre, the date of release. Oh, it just changed on me. I thought I was looking at La La Land. Close. This is an advertisement up on top apparently. So yeah, you see this, date of release, genre is available, duration, PG-13, some rating information, some picture, some trailer, and that detail that you're looking at. I don't want to play the trailer, so I want to go back to the movie details. And there's this picture of the people that actually are in the movie, like here, for example. And these are the actors. So you want to know about those people and you want to expose that information to the end user, right? So there is this metadata, which is data about the movie itself. That data also needs to be captured and needs to be stored along with the entire record for that particular movie. And you have to repeat that exercise for the entire long tail, for every movie in there. And the movie list grows over time and all that good stuff, but it is a large collection and it's quite a bit of work. And that metadata will actually become visible to the people who will eventually start the Netflix. I downloaded this app, by the way. So this app that I have here will give you the choice. I still don't have a login, but I'm just going to give you a flavor of all these collections. Like here you have the pets thing, whatever this thing is, the Family Guy, Dory, and Minions. And these movies are in the listing that is available and is exposed to you as you go and explore the Netflix app on your target device. So this device happens to be a Surface PC. And so that app here is specifically targeting me at this moment. So it is exposing this entire what is called long tail collection to me through the app. but only a subset of that gets exposed at a given time. And this decision about, million, maybe multi-million movies, we have millions and millions of movies that are sitting in our bucket in that location, and we have to expose only a portion of that to a given customer depending on their interest. So we have to somehow figure out what is their interest, what could be their interest. And so there is something that Netflix has a lead in being able to understand what is known as your preference, what you may be interested in. That is something that they actually have spent quite a bit of money and effort in coming up with a recommendation engine. Netflix, $1 million prize. And so you can see that challenge. They put together a challenge a long time ago, which was won by a group of people that came up with this algorithm called the collaborative filtering algorithm, which was, I think the result was that it went to, who won it? I think it must have, here, this Belcour's Pragmatic Chaos. That algorithm won the Netflix prize of $1 million as the best prize for finding out collaborative filtering, and using that method is what Netflix is able to come up with a representative subset of recommended movies that you may be interested in watching. And so what I have seen is they somehow magically figure out that I may be interested in watching Indian movies. Maybe that is easy. Just by looking at me, you can tell that I might be interested in Indian movies. But apart from that, the fact that I am logging in from a location, from a given IP address, that my name is like this, that my credit card number is like that, and they may have a variety of data gathering sources that helps them in gathering data points that will help them understand what would be that subset of this entire long tail that I may be interested in browsing through. And so that representation will pop up in the app as I log in. And then through that, I may be able to select this and that and watch and on demand, and all that will happen. One thing that I want to ask you is this file that gets generated for a variety of scenarios. The question that I want to ask you is, let's say a customer who is currently going to watch a movie using the Surface device. It's a PC device, and that person is watching it here, the same movie, La La Land movie. And then what happens is that person decides to drive. And so he sits in the back of the car and somebody else is driving him around, and he decides to pick up his iPad. And it is connected to the internet, and he wants to continue watching this La La Land. This La La Land movie is like 2 hours for some minute long. And so this person started watching at t equal to 0 and watched that movie all the way through 13 minutes and then stopped it on Surface. And then he sits in the back of a car and he has his iPad in his hand, and then he wants to resume the same movie. So the question I have is, for this customer experience to be of a continuity of sorts. So like, for example, you watch this movie all the way in your Surface device for the first 13 minutes. The expectation that the customer will have is when they watch on the iPad device, that they would not start from point 0, but they would assume that they will start from point number 13 minutes and then go from there, because that resume action should actually kick in automatically. So for this kind of an action to happen on these multiple devices, this device stops at this point at 13 minutes and this device starts. It was inactive before, and this device should start from this point onwards. For this kind of a scenario to be enabled on multiple devices, giving customers a choice to be able to resume from whichever point in time they happen to have stopped, watching a particular movie that they were selecting in La La Land, for example. And what would it take to enable this kind of a setup? That's the question I have. So I hope you understand the question I'm asking. The question is essentially what I just said, and the answer is what I'm expecting. What would it take to enable this thing? Right? You have a person choosing multiple devices. They switch devices in halfway through a progression of watching something. So what would it take?
Well, the server side would have to know where you're at or how far you streamed and make note of that and store that on the server side. Yeah.
Yes. So how will server side know where you are at? They would expect that the client reports that status, right? This client has to continuously report where are they in the middle of the movie, at what point they are. In fact, that point in time, or rather I would say timestamp, timestamp needs to be continuously reported back to the server, to the cloud end, as to, I am watching this movie, La La Land, on the Surface device, and I am at this timestamp, and I have successfully watched it up until this point. That's the record that you need to continuously send back from the client to the server, to the backend, so that the backend will know what has happened up until now, right? And then when the person starts the iPad and he or she connects back to the client, back to the cloud, and expects to resume, the server already knows that you are at that point in time, and then server will intelligently send you or stream you not this version, but this version for the iPad. It'll automatically switch over streaming to the right target format from this point onwards, from 13 minutes timestamp onwards. We'll pick up the La La Land iPad version and then stream this to the iPad target. And again, all those collection of statistics. This timestamp is just one statistic that it's collecting. The back end is actually collecting. The question that I have again now, which is a different question, which is what other statistics need to be collected from a client device like this, apart from the timestamp where you are at? What else should it actually collect? And how to monitor what is going on from the client's perspective? You want to make sure that your customers are super happy and delighted about binge watching, a series of whatever things they want to watch, whenever they want to watch, wherever they are at that moment, without hassle. That's the goal. So with that goal in mind, what metrics they need to monitor in order for them to succeed in making the customer happy in binge watching whatever they have in mind? And that's the question. So what is it that you need to monitor? And one of them was timestamp. What else needs to be monitored? That's the question. So two. Latency. Yes. Bandwidth. Right. What else?
The file type.
The file size, did you say?
File type. They need to know what
the type of device. A type of device. Yes, correct. Yes. The type of device as to what's the client device? Is this iPad? Is it Surface? Is it something else like that? What else? What else do we need to collect from a ensuring quality perspective? Those quality metrics are critical to success of Netflix, by the way. And so some of the things that are not super obvious that needs to be collected is things like time to first frame. Like the moment you click a button on a movie, like for example, I open up my app and say, boom, play this La La Land. From the moment you click the button to the moment the first frame pops up here, this duration of time is the time to first frame is something that needs to be as small as possible. It can be slow. It can be a long duration if you don't pay attention to it. And what this does is actually cause frustration. This is the single biggest point of frustration, by the way. Hey, I am clicking the button and the movie doesn't play. What's going on? That's the frustration that you want to cut down right away. And so to make that happen, Netflix, first of all, has to measure it, but more importantly, has to have a method of being aggressive. Aggressive in terms of whatever they can do, they have to be aggressively making sure that this is reduced to close to zero. It's not mathematically possible to become zero because there is some delay in the moment you press the button to the moment the first frame of the movie starts to play. First frame starts to play. And so that has to be cut down to the lowest number humanly, or rather practically possible. So they have to be aggressive. And this aggression can happen in a variety of ways. For example, the idea is that you have a device like, let me just pinpoint an example. So let's go there. So I will pinpoint at a device called Amazon Fire TV RAM. Let's see how much RAM they have. So you will see that this Amazon Fire TV has a box that contains quite a bit of RAM. And what they do with that RAM available, okay, where is that RAM here? And not only the RAM that you have is about 2 gigs of RAM sometimes, sometimes it is 1, depending on the machine type, plus they also have some hard disk locally available. So what they do is they become aggressive and they figure out that you are hovering on a particular movie, or that you may have been sitting on that movie. For example, if I go and hover on a particular product on Amazon.com, I'm lurking around this particular product, say for example, in my cart. So I have nothing, and so I can maybe go lurk on this jump rope, for example. And so I'm lurking on this. They already figured out that I'm going to click on this item and maybe add to cart. So that's a similar action that you have to look at from a customer's perspective, that the person may be interested in watching that particular movie that he or she may be lurking around. So you see that I did not actually proceed through the checkout, but I have clicked on it once or twice, read about it, read the details, and maybe explored some other items that are related. So they already know that these movies are the class of set of movies that the person may be interested in. So it can take into account the aggressive behavior and attempt to prefetch a portion of the initial segment of the movie already, even if you did not actively click on the play button. And that is okay, because you can afford to do that because you have enough storage as well as enough memory on devices these days. And so what companies like Netflix do, and so does companies like this guy, what is this thing called? They have a similar product. They call it Amazon Movies or Videos or something like that. So some product, very, very similar product. It's called Amazon Video maybe. So they have a similar offer in which, Manchester by the Sea. It's a movie. It is exclusively on Amazon original, and so you can get this movie only on Amazon Prime. So Manchester by the Sea, if you attempt to click on it like this and don't actually play the play button, so I'm not clicking the play button, but the fact that I am hovering on this movie right now, Amazon knows that I may be interested in clicking the green colored button that says watch now, and might actively aggressively prefetch a portion of the movie right now already without me asking for it. And what does that translate to? It translates to this idea that you are able to create this illusion that the moment you press the play button, this triangular button, that the movie starts to play almost instantaneously, because they are kind of, being aggressive about it. They prefetch. And so this aggressive prefetch is a way to implement in the client side, where the client is smart enough to detect and is able to prefetch content from the cloud side, and to reduce the time to first byte. And that is a metric that is measured very aggressively. Another metric that is important from a user's perspective is how many frames are dropped per second. So frames are dropped. What's the frame rate? Is it good enough frame rate? If you know that a human eye, if you have a person watching, human eye cannot detect a picture from another picture and another picture in a series represented in front of them if the number of pictures per second is more than 24 or 25, something like that. One of those numbers, if you go beyond that number of pictures per second, the frame rate goes higher than that number, human eye will think it is a movie, not a series of pictures. That's the design of a human eye. So if you go beyond a certain number of 24 or 25 frames per second, people think you are showing them a real life movie, because they cannot really tell it's a picture after a picture after a picture showing up and building up in a sequence. If you do fast enough, and that's the minimal frame rate you need to have. And if you don't have that, and you reduce the rate of frame below 24, then people can detect what is known as stuttering. A movie is showing you picture after picture, and it doesn't actually play like a regular movie should. And so this is another characteristic that needs to be measured as to what's the client side frame rate. Is it good enough? Similarly, if they're dropping frames, which may be something that you can probably witness right now, because I am doing such a thing with you live. I am actually streaming video right now to you. And so you can see, let me see if I can show you some metrics around this same idea that I'm discussing right now by opening up my settings section and see if you can see those statistics. I don't know if you can see the stats, but can you? I'm showing you some stats. I think you cannot see the screen, but I'm not sure. My question to you is, are you able to see some statistics showing up in my computer screen?
Yes.
Okay, so here you see that I am showing you that there is a latency of 30 milliseconds, jitter of 5, packet loss is 0%, which is nice. You see the resolution is 160 by 9, and these things are for my video that I'm showing you here, this video segment. This whatever window that you see my hand shaking, that video segment is what I'm talking about in this. And my frame rate is kind of slow. It is 12, 11. It is slow frame per second. So that's why the movie video quality that you see is not as good as it should be. Now, having said, let's go back to the statistics screen again, and let us see what the result is on the screen sharing portion, meaning the main desktop that you see, the desktop itself. Here you can see that the frame rate is also slow. It's 11 or 12 frames per second. The resolution, however, is pretty good, 3000 by 2000. So it's a full surface display. That's a phenomenal resolution right there. However, packet loss is good, 0%. That means there is no loss in the number of packets that I am transmitting to you. And jitter is 5 milliseconds and latency is 27 milliseconds, so pretty good. Let's see the same thing for audio. You can see that audio frequency is 24 kilohertz, which is kind of suboptimal. It should be, from a music quality perspective, at least 48 kilohertz. But again, I'm not a singer, and you don't mind me listening to me like this. I mean, I cannot do better than what I speak. And so that's what you get from an audio perspective, from a quality perspective. You also see latency numbers, jitter numbers, and packet loss numbers. And so overall, looks reasonable from a video transmission perspective, which is happening right now. And so these are the characteristics and the statistics that you need to measure. And the aggressive prefetch is something that I cannot enable for you, because I am not coming from a bucket. I am a real live person, right? So I cannot actually enable aggressive prefetches for you because I don't have it. I mean, I haven't spoken the word I will speak in the next 2 seconds. So that is something that you have to understand, that if it's a live event, like right now, this aggressive prefetch cannot really work because there is nothing to prefetch. It's only when you have an item sitting in some bucket somewhere that you can actually do an aggressive prefetch and show people, hey, here is what you already have. We already downloaded it for you, and just play the play button. It will play for you smoothly without any issues in terms of frame rate going slow or any such thing like that. That is something that you have to understand. Now, having said this part, let's take another example, which you may or may not have seen. But that example corresponds to this idea of a product called WhisperSync. Have you heard of this thing? WhisperSync. Anybody knows about it?
No.
Okay, so let's go look at it. So WhisperSync is a technology that Amazon has developed for Kindle. And what this does is actually beautiful. You will understand it at the moment you see it. And what this does is, if you have a Kindle and a audio book and a paper book, I mean a Kindle book with you from the same company, it will synchronize across Kindle devices and apps. So what does that translate to? Something like this. If you have a book, let's say the book is the Goal book, and you have that book in your ebook format in your Kindle, and you read that book from page number 0 all the way through page number 37. Good. And the pages are like about 650 or so pages, so lots of pages, but you read it through page number 37, and then you put the Kindle down on the side. You also happen to have the same Goal book in audiobook format, and you are now in the car and you want to drive, and you want to put that audiobook, this Goal book, on the play button. Now WhisperSync is smart enough to detect that you have already read up to this point. So when you play that audiobook, it will automatically skip ahead to that point in time as opposed to in pages. So there is a translation between time and pages that takes you automatically to this point in time in the audiobook, and it will play you from this point onwards. And that is the idea behind WhisperSync. And that technology is pretty fancy. If you think about what's going on under the hood, is for every book, you have an ebook as well as an audiobook. There has to be a method of translating pages into timestamp and convert and remember where you are at a given time, which page are you on, and which page at which you put the Kindle down, and then pick it up again in another device in a different format and resume from that point onwards. And then you listen to it for like 30 minutes as you drive to your destination, and you put the audiobook down and you open Kindle again. It will automatically resume at whatever the appropriate page number is, say page number 315. Oh, I'm just making it up right now. But it automatically picks up that particular targeted point in time, translated into a page number in the Kindle book as you stop driving, and you now able to read the book itself. So that synchronization technology is WhisperSync, is what you're looking at, is conceptually what this idea of switching between say an iPad and a Surface is. What it's a simpler version, by the way. This Surface and iPad switching is actually quite a simpler version compared to WhisperSync. WhisperSync is able to translate between page numbers and timestamps across two different formats, like a book, ebook versus a audiobook. This is very hard to implement. That's the reason why you have not so much coverage of books in WhisperSync for audio. Let's see, WhisperSync for audio or voice. And so that coverage is not that heavy yet. But WhisperSync for voice is coming up slowly. You will have buy the book. You have to buy the Kindle book, buy the audio companion, and then switch between reading and listening on the Kindle app versus listening to on the audiobook on a tablet or device that you might have. So that translation or carrying forward and backward timestamps versus page numbers is a nifty action that Amazon has implemented, but not many books actually are covered in that model. So you might see that not every book is covered like that. So you can see some examples, and you can read more about what this thing is. But it is a fancy technology that people have implemented in Amazon. And a similar idea at a simpler scale is this idea between switching between Surface and iPad. So that's something I wanted to bring up to your attention. What other metrics do you think that this company needs to worry about apart from these guys: timestamp, bandwidth, latency, and jitter, and frame rates, and number of packets lost, time to first frame dropped, frame rate, things like that? What else do you think that this company should measure? And what specific action should Netflix do specifically in the perspective of making sure that a customer doesn't end up calling Netflix? Because once a customer calls Netflix, that's quite a bit of loss if you think about it. Just calling somebody on the phone in a customer service setup can cost the company approximately $30 to $50 per hour of time spent with the customer. It's just the cost of the people that will manage and handle the phone call. And that is something that they want to avoid, because a Netflix typical bill is like $10 per month. And that will immediately drive down your profits, actually go into negative. You will make a loss the moment a person calls. They're paying you $10 per month. They make a phone call to you, you are already down 3 months of revenue. So that is something that you want to avoid. You want to avoid people calling you on the phone. So you want to provide proactive customer service, proactive. So from that perspective, what do you think Netflix should do? And we have a variety of ways of collecting metrics and statistics, and the endpoints for reporting and smart and all that good stuff. But we want to make sure that people don't call us. So what in the world can Netflix do to avoid people calling them and provide proactive service? So what would those ideas be? An idea that already is a plane calls for help. A plane, as in not the pilot. A plane itself detects that there is a problem, and the plane calls for help, and Boeing is able to send a replacement part or something that is needed in the right location at the right time. This is plane acting and sending a message to the ground, asking Boeing company and the support supply chain to automatically deliver the appropriate solution at the destination at the right time by itself. This is not the pilot calling, but the plane sending data. So you already know these things. Now, what does that translate to? Netflix, from a device reporting its own health, is something that you have to think about. The health of the device, health of how the video is playing on the target. So this is a device, some random device with a random customer, and playing a particular movie. It is going on. You want to have this device smart enough to report proactively whatever it can to avoid a phone call. So what would you do? What would you want Netflix to be able to collect in terms of characteristics or measurements that will reduce the chances of frustration leading to a customer service call? That's the question I have. What do you think? Any takers? Nobody's taking it. Absolutely. Okay, let me describe those ideas to you then. So what we have to make sure is that this device, or all these devices, the iPads, iPhones, Surfaces, Xboxes, and Blu-ray players, and TVs, and all the devices that Netflix supports, needs to send whether the movie is playing or not, and how fat is the bandwidth at all the time. If the bandwidth shrinks for some reason, and this happens many times, it happens that the bandwidth actually shrinks. It becomes small for some specific reason sometimes, and for other times the bandwidth becomes a unknown variable. Bandwidth is an unknown variable. As you can tell, I can show you some examples. Maybe you've seen it already. It is the internet end to end can be a random variable. It can change. The bandwidth can be fat. The bandwidth can be thin, depending on time of the day, location, what other people are doing, what is your location, are you driving, are you steady in a location, and also some business related issues that also pop up in the same constriction of bandwidth. Another issue that pops up in the same topic, which is also business related, is net neutrality. You will find, you may have seen it already, that sometimes if you are a Comcast customer, that Hulu works just fine, but Netflix doesn't. Have you ever wondered such a thing happening? If you play Hulu, beautiful, no problem. Try playing Netflix or Amazon TV, doesn't work. Have you ever wondered why does that happen? Anybody? Why would that happen? If you are a Comcast customer, Hulu works fine, Netflix doesn't. Why? Comcast is your cable provider. And you may have seen this.
They're probably paid by Hulu.
Sorry?
They're paid by Hulu.
Yes, Comcast is owned by, Comcast owns Hulu. Mm-hmm. It is their own company.
Figured it was money.
Exactly, right. It's money, right? So, in fact, Netflix has started paying them money. That's the problem that's a problem that is basically defeating net neutrality. So you can see that Netflix, Comcast, net neutrality. You can see those, cases. Where is that? Yeah, there are lots of news articles you can read about. Essentially, it boils down to Netflix getting forced to pay Comcast because Comcast is feeling threatened, and so they are deliberately reducing the bandwidth for Netflix. So you have to understand these things. Then they cannot necessarily be technical alone. They can be business related, where companies like Comcast have the control. They have the last mile for the end customer, and they have presence, and they have almost a monopoly. And so they sometimes behave improperly. So much so that, people hate them for that reason, that one reason. In fact, you may have heard of a survey of people in the US who were asked, who do you hate the most? And so people rated. And of course, the first rank went to Comcast. But the crazy thing is, the rank number 2, people who hate talking to, was the IRS. That means that people will rather get audited by the IRS than talk to Comcast customer service. That's what it means. It's kind of crazy to think about it. How evil can they be? People are willing to get audited, which basically what that IRS was number 2. And Comcast takes the crown jewel, ranked number 1 in terms of worst customer service. And they are somehow grown into that because of monopolistic reasons, which is what you see occasionally. And I'm not bad-mouthing them, but yeah, I am. Yeah, whatever. So I am using them, by the way, right now. They can throttle me down and cut my broadcast to you right now as I speak. But I have a backup plan, so don't worry. I have I always have a backup, and I can get rid of them. I can still continue my broadcast to you and all that, because I know that it's a business issue. But I still use Comcast because that's the only choice we have right now, practically speaking. I have a different choice, which is smaller bandwidth, but it works. It works out okay. So I keep that as a backup, and that's why, this discussion. So from a customer service point of view, you have to make sure that the bandwidth, it might change over time, and you have to proactively report back to the cloud end that the bandwidth end to end is not good enough to sustain a 1080p video stream. Cannot do this. So what do we do now? We downsample automatically the next series of streams that will go down to that device. On the same fat pipe became thin, you downstream it to a slower 480p, which will of course reduce the bandwidth requirement, and will not be as good as a quality that you will have, but then people may not notice. And if people do notice, they will eventually complain about it. But this is a quick step to downsample the stream that you are sending to a lower resolution frame for the time being, where the bandwidth somehow thins out. That you have to adjust whatever you are sending on the fly without asking the customer to call you. And you can see sometimes these things happen when you go, say visit here on YouTube, and you try to go, and YouTube might say occasionally that, you know what, is your video not good enough, or something like that. They might say that if your video is not good enough, you have a problem with your Comcast or some other cable provider. And you will see those things happening as occasionally you will play some video. So let's say this video plays, and you can see that this quality metric you can adjust yourself here, for example. So I'm able to choose my quality metric myself, but this transition happens by itself in case where the client is able to detect that there is a bandwidth problem, and it would automatically select and drop down the quality levels by itself to a point which is still bearable. And when it goes below bearability, at that time, when it cannot further go down without having the customer notice a quality problem, at that time, the app needs to actually stop playing. There is no point playing a bad video. Instead, you are better off playing no video at all and telling the customer to call Comcast. That's what actually Netflix does. Is not Comcast, but they will detect who the company is that are providing you services and call them out by name and say, hey, you call the company that is giving you internet service because their bandwidth is too slow to actually accommodate a good enough video display for you. So instead of running a crappy video on your screen with a 320p, I would rather not play anything and have you call the company that gives you internet, and thereby diverting a phone call to somebody else who may be the real problem. And that is something that you have to understand that you need to do in order for the company to survive. If they don't do this, and they can either slow down the bit rate, slow down the quality, and thereby being still able to be passed through a thin pipe. But at some point you have to say, no, I will not play a bad quality video, because it does not make sense. I would rather stop playing the video, because playing a bad quality video is worse than no video at all. And that is something that you have to detect this on the fly as things happen, as bandwidth changes, as latency increases, jitter increases, all these things, packet loss increases. Sometimes people notice that they start the microwave oven and the Netflix video starts stuttering. You can see why it happens, because microwave might interfere with the local Wi-Fi and can cause packet loss, and then the video doesn't play smooth. As soon as you shut off the microwave, things are all okay. And those things you may have seen with older style Panasonic phones. And so these are old stories that you may have seen or not, but I'm just pointing it out to your attention, is that providing proactive service to the best extent you can is essential for sustaining a business. And that's what Netflix does. So let's finish off this discussion on Netflix and change our topic to another one. I want to conclude this from a processing pipeline. We have these processed videos stored in our bucket. In addition to that, you need to also store the metadata about all these videos in the long tail in your data store. Now, this data store could be your MySQL database, could be some other database like Postgres or Mongo or whatever database you choose. You need to store that data in some data store, which will store the metadata about the data, right? Metadata. That metadata needs to be stored for every movie that you have in your bucket, and a pointer back to the movie file itself so that you know where the movie is sitting in your bucket. So the pointer will include the name of the artist, movie, the title of the movie, the ranking, rating, who the actors are, their pictures, some trailer, and all those details will become your metadata. And the actual video will be a pointer sitting in the bucket. That's where you will store the actual videos. Now, once this data gets populated in the data store and your movies are processed and sitting in your S3 bucket, now you're looking at the delivery pipeline. Like you want to now reach the customer. So the customer again is this guy. And this time, this person who used to be a Netflix employee in our previous discussion, or a bot who's uploading a video file into your pipeline, now I'm going to reuse that persona as an end customer who's going to attempt to watch Netflix. So this customer goes to netflix.com, not the upload site, not here, but the netflix.com customer facing site, for which they need to also go do a DNS query on netflix.com. And that query will land them here to this load balancer right here. And that is where you see when you visit netflix.com, or when a device like Xbox attempts to run the Netflix app, it will reach similar endpoint, which is basically rendering the experience that a customer is expecting to see in the app, in your browser, in your iPhone, in your Surface, wherever you are. You're basically seeing this experience that these servers, which are web servers, are trying to render to you. And again, all of these guys are also auto-scaling, so they can scale out and scale back in depending on demand. With not many customers, you can scale that back down. And remember that these machines are not spot instances. Not. You cannot afford spot instances here for a simple reason. This is customer facing. You have real people who are your customers, paying customers are coming and visiting you. You cannot, absolutely not afford to have a spot instance. So no spot, just plain old machines that you can get guaranteed, at least a minimum set guaranteed in reserve, kept for you for perpetuity, and the rest you can add on demand and scale out as needed. So scaling will happen as you need, and shrinking will happen. And so growing and shrinking will happen. And these servers, these application web servers, will provide that experience that you expect to see, that these customers expect to see when they visit netflix.com. So for example, I visit as a proxy, I will go to say Hulu or start my trial, and then I sign on to see all these things, Hulu originals and some movies and Spectre and kids and all those things. So I'm presented with this view, which is basically a representation of what is being sent by these web servers. And they are pulling up data from the database and presenting to me a view of the service that this company provides, which is Netflix. And that view is generated through the metadata stored in the data store. And at some point, when this customer decides to press the play button or at some point when this logic that you have already knows that you need to be able to aggressively prefetch a particular movie at least the beginning portion of a particular movie, that prefetch action is offloaded. It doesn't go from this route. It does not. It is completely offloaded to a content delivery network, CDN. And that is where it will come into play. And you can see that the CDN is represented in this picture here, content delivery network. And this CDN, there, Amazon is showing that you're going to use Amazon CloudFront. But again, you can use any CDN. That doesn't have to be this CDN. And what this CDN does is actually grabs that movie from the bucket from here and will render that experience to the client endpoint, either from an aggressive prefetch perspective or an on-demand perspective. Whatever you have will go out from a content delivery scenario to the end customer, who will then enjoy the movie. There are also lots of other things that will collect statistics from the client experience perspective and store them here in some other data store like this. That is not represented in this picture, but I think you understand that because we discussed that. So like these things, for every single user action, you need to have a set of services that will respond to that user action. A simple scenario would be a new customer pops up, new potential customer pops up. So it's not currently a customer, but could become a customer. So that new person pops up, he or she is lurking on the website and they want to sign up. So this sign up is a different experience than the watch experience. The watch experience happens when you log in. After you log in, then you get to watch or browse. So maybe first browse and then watch. Those experiences will happen after the fact, after you log in. But when you're signing up, it's a completely different system that is catered towards selling a service to you. So it's a marketing system. It is not a movie watching and browsing system. It's a completely different site, a completely different product that is focused on making sure that a random visitor converts to become a customer. So this conversion has to happen so that this becomes a signed up customer with a credit card in place, so that when they sign up, that they can then transition to this state, which is a login state. So they are logged in. Now they can browse, they can watch, and they can log out. And that's the two different systems we are dealing with. This is the marketing system. This is a play and browse and play system. And so it's a different system that you're looking at and that you have to construct. This is not represented in the chart. Then there are other systems you need to have in place, such as a system to collect statistics, collect metrics. And that collection has to be basically being received from your endpoint devices globally, wherever your people are, wherever your customers are. These people, these devices will send you stats, send you metrics about whatever is going on, which movie is playing, what point in time, what the frame rate is, what the, all those metrics that we discussed. And there are more, by the way, that Netflix needs to collect and aggregate and act upon. So this action has to happen. So it's a action has to happen in which will require. So this is a collection phase of data. You have to also do some analysis on that data, which can also happen in the cloud, but it needs a separate structure, which requires a separate setup, just like this. This was for media sharing. And you will see other examples as we go through as to what does it entail when it comes to analyzing something. So for analysis, most clouds provide you analysis frameworks that are preloaded as services that you need to be able to consume and put this collection of data into analyze that. And then comes the next action to basically act on the result of analysis, act act on the result. So on the result. So whatever analysis that happens on the data, that you have to collect those metrics and then analyze them and then act on them. And this action may actually go back to here in terms of what the user is doing, browsing, playing. You want to prompt that user to do something different, or maybe tell them to contact Comcast because Comcast is limiting bandwidth unnecessarily. And so those situations might happen. Maybe there is something else going on, that video is just unable to connect to the internet. So if that is the case, the device needs to be able to just tell unable to connect. I mean, as simple as that. So those are the variety of scenarios that we need to think about from a company's perspective to basically get to a point where we are able to make our customers happy, keep them happy, and have them not call us primarily. Because the moment a person calls you, you lose money. And that is a fact of life. So with this, I would stop discussing this particular case, take a short break, and take a very short, small, different but related case that we'll spend some time discussing about. It's a fictitious case that we will talk about after the break. We will discuss this and then do some exercises with understanding how does this all apply to a variety of clouds. We'll take 3 examples and also discuss this thing that I mentioned early on, which is Terraform. So we'll discuss those things as we progress along. But right now, taking a short break, and then we will discuss a fictitious case study. It's a short one. It is totally fake, but it's worth discussing. So with that, I will initiate a timer. What just happened? It did not type properly, apparently. Okay. Okay, there we go. So starting the timer right now. Hey guys, let's see if you're back. Yeah, I can see that you're back by looking at your mouse movements, keyboard movements, and things of that nature. This thing tells me that you are back or not, which is crazy. But I think there is some smarts in the system here that looks at keyboard and mouse activity and user activity and is able to detect whether you are back or not. Looks like you are, all of you.
Tricked you. My mouse.
Sorry?
Tricked you, my mouse mover.
Yeah, yes. So let's continue discussing on a different case, conceptually similar, but slightly different. And it is totally fictitious. So that's what I would like to discuss next. I will bring up a new sheet of paper and put that right here. Make it a sub page and start discussing that idea. This is a case of what I will, in one sentence, call it video 911. That's what I would call it in one word, maybe two words, video 911. So you know already what a 911 is. I don't need to tell you, but our idea is to convert and create a product for the US to allow video 911, which is let me describe it. Let me describe what this means in practice. So there are some assumptions that we have to go make before we can discuss this. The assumptions are, first one, that the federal government has given us unlimited budget, which is kind of crazy. But that's the assumption, unlimited budget. The second assumption is everybody in the US, the whole US everybody has iPhones, which means they have ability to do FaceTime that exists. The third assumption is that everybody in the US has unlimited data. Doesn't mean unlimited bandwidth, just means unlimited data. It's there, everybody has it. And sufficient battery. So that's another assumption. Most people have sufficient battery charged. It's kind of arbitrary to assume these things, but that's the assumption set. So no battery issues, no connectivity issues. So that's the assumption. Now with that, let's define the problem. The problem that we have currently, as you know, there is a thing called 911, and that you already know what that means. So I don't need to describe what 911 is. But what we are trying to evolve is a new system of video 911 with these assumptions in place. So my question is more of a very broad, open-ended question, is how would you start thinking about implementing such a thing? where would you start thinking? And how would you evolve your thinking from a implementation point of view to ultimately get to a structure or a setup that allows people to call video 911? And by that, what I mean is, they will just pick up their phones and dial 911, and they will be able to show what is going on, not just speak of what is happening. And that is this video aspect that I want to include as an enhanced feature to allow law enforcement, to allow emergency workers, to allow ambulance and other things. I basically brought three things, right? There is police, there is emergency, and then there is medical. Those three types of emergencies are typical. There are other types occasionally, but those three, we need to primarily focus and make sure that these types of service providers can actually provide you service when people call video 911. They should be able to show them, not just speak to them. That's the situation that we want to implement. The question I have, it's more about how do you think, or how do you begin to analyze, begin to think about what does it take to implement such a structure, such a setup? What would it take? And how would you, more importantly, how would you begin thinking? That's the primary thing that I want to focus on, is where would you begin thinking and how do you build your thinking? Now, we don't want to implement this. It is actually not possible. These assumptions are all false. You cannot, that's not true. And so we cannot actually implement it. But all I want to really do is to focus on understanding how would you think in solving this scenario, this problem you want to implement with these assumptions in mind. Where would you begin? So it's more of me listening to what you have in terms of your thoughts is what I want to understand from you and discuss briefly. Not spend too much time on this because it's fake, as you already know. But I just want to know that how would you think? So help me understand, where would you begin your thought process? Anybody? Nobody?
So, as I understand it, 911, is an important thing. So, quality of service during the call may be a big part of it.
Yes, quality, absolutely.
And kind of a higher guarantee that you're going to get through versus other types of calls.
Yes, right. Priority of traffic. Priority of connection traffic, right?
Correct.
Yes. What else that would you think in terms of implementing?
Automatic metrics of where you're at, geographically or
location.
Location,
yeah. Right. And GPS, things of that, that will allow these agencies to detect your physical location, right? The fire truck can come and reach you. Things like that. What else? How would you think about from a client endpoint perspective? We already have iPhones. That is understood, right? We assume that we have. But on the cloud side, what would you put together? So think in that direction. What would you need here? And how would you structure this side of the equation? The client side is kind of understood. We know we have iPhones and we have FaceTime and all that good stuff. What would you need here?
Well, high availability, I guess, would be
yes.
Maybe.
High availability of what?
Bandwidth and storage and communication in general.
Right, bandwidth, storage. And in terms of the application sets that you would like to have structured here in the cloud side, how will that look like? Let me see if I can pull up a picture to help you think in that direction. So I'm going to grab some example pictures and see if I can pull out something. It's a very similar diagram that you saw before in the case of Netflix, except slightly simplified version that you will see some example that I'm going to pull up right now and see if I can bring it up. Actually, we can reuse the same picture in a sense. And to describe what we are talking about, let me see if this may be slightly different. So I'm going to pull it up and see if it looks different. This is something that we may use as a reference, because what this does, a part of this does is enable the scenario that I'm talking about, which is the 911 scenario, enhanced video 911. So I'm going to download this and see how we can put this in use in our discussion. So downloading it right now and putting it in the segment here in downloads, and I'm going to open up in that editor where I'm playing around with. So I'm going to close this and not save this, and then open up the other one. Where did that go? There, maybe open. Yeah, this one. So the reason I want to discuss this picture in the context of what we're discussing is primarily this point here, live stream source. That's your FaceTime sending video, right? And for a device to send video to somebody, which is, say, for example, an endpoint that is going to listen to your incoming video and will actually capture that and store that in some location. At the same time, have a user who's like an emergency 911 operator, for them to be able to understand what you are sending in terms of an audio stream, in terms of a video stream. You want to be able to capture that, store that in a bucket, play that back, interact with them as they speak to you, as they show you what you have, and then have this emergency operator decide whether to send police or fire department or medical people. Who do they send, depending on the need of that particular scenario. So from a implementation perspective, this chart doesn't actually do justice to what we are discussing. But what I would like to discuss is some of the key points that I want to bring to your attention as you think about the video 911 discussion, which I would like to keep it short, not spend too much time on it, because primarily it is fake. But a couple of things that I want to focus on your attention is the idea is that if this is the US, I'm just drawing a rough map of the US. So here you have Washington, and here you have Florida and things like that, New York. And so if this is the map of the US, you have to basically identify and divide in terms of counties, if you will. And for every county, all over the nation, you have to understand how much traffic there actually is on a historical basis from a 911 perspective. That data you can already collect. With that data in hand on a county by county basis, you can then estimate how big of an infrastructure do you need on the back end for every county as you go and proceed to build your cloud infrastructure for that particular region, for that county. As you start to estimate, you have to also estimate from the person who has a phone in their hand, they're going to send a video stream, audio video stream. You have to assess the bandwidth needed right here at the point of the device itself. So you can test that very easily by making a FaceTime call and measuring how much bandwidth is consumed. I have done this test myself, and when you do a FaceTime call, typically it takes about 2 MB per minute of the data is consumed. So you can, based on this number, you can estimate the bandwidth needed from one phone call, one video 911 call. You can tell this is the amount of bandwidth that you expect to consume as you interact with a person who makes a call. Now, you have to estimate the same and extrapolate that number based on historical traffic patterns to a variety of counties across the globe. And you begin with a pilot of 1 or 2 counties as you begin to explore and test your initial thinking about how would you implement. So maybe you pick 1 or 2 counties and then implement, making sure that you have enough bandwidth for estimated number of people that call typically in that county, and appropriately put together back-end infrastructure that can handle these incoming calls on a periodic basis. You will find that there is a strange situation here when it comes to 911, or rather, I would call it V911. That strange situation, which is very different from any other business, is that this has a unique nature to it, and that nature is called emergency. And the reason I am discussing this is primarily because of its different nature of characteristic from a usage perspective. It's emergency, which implies that you have to make sure that the utilization of a machine that you might have, or a collection of machines that you will put together, needs to be low. You cannot load up. Like a classic situation would be something like this. You have this computer that I'm using right now. If I go and check its task manager and see the characteristic, this machine is loaded up like 74% CPU. It's quite heavy in terms of usage. Ordinarily, it is not that heavy. If I continue and sustain usage on that amount of CPU consumption, if you see right now, if that goes on forever, that becomes a problematic situation that this machine cannot really handle immediate action expected of it. You can see that basically translates that the machine becomes slow. And you don't want things to become slow when it is an emergency, which basically boils down to this idea that you have some kind of a resource and you want to make sure that it is fully utilized. And that's common business, fully utilized, so that you are loading it up all the way to say 80 to 85% of usage, and that is considered nicely used. Sometimes you are not utilizing that machine too much. So it's like 5 to 10% of machine being used, and that is called underutilized, which can be leading to unnecessary cost. Machines can cost you money because you are underutilizing them. Here it's a decent utilization, so it's decent. And a third scenario comes into play where you have a machine that is like close to about 95% utilized. And this scenario is actually, I would call, overutilized. The reason I call it overutilized is because this machine that is running at a 95% utilization does not have room to take on new and emergent work. So if suddenly new action is expected from this setup that is already running at a 95% utilization level, that you cannot put this machine to do something else because it is already quite heavily utilized. So these utilization factors, if you look at, and now think again about V911 and emergency services, what kind of a utilization structure would you like to have? Decent, over, or under? What would you prefer in an emergency setup? From a cloud usage perspective, you will have a backend in the cloud. What kind of a utilization factor would you put? Decent utilization, overutilization, or underutilization? what would you pick for emergency services?
If cost was still unlimited, then underutilization.
Yes, exactly. That is exactly the right answer. And you can see that happening in real life. In real life, if you go visit the Redmond Fire Department, or just any fire department across the globe, across the nation, I should say, in the US, you see Redmond, Washington Fire Department, and other places. They have similar setups. What do you see? You see that 4 or 5 nice shiny trucks, fire trucks, sitting here with people. And these people, all they're doing is basically, making sure that the truck is clean, nice and polished, and it's filled with fuel and water and whatever is needed to make emergency services, and they are ready. But idling. They are idling all the time, and there are 5 trucks and sitting doing nothing. And I am very happy about it. Like, exactly, because I want them to be idling all the time with a utilization number of 0%. That's what I would like to have. You know why this is a good thing? It means there is absolutely no problem in the nation, that there is no emergency needed, no need of police, no need of any emergency, no need of doctors, because everything is all going good, nice and well. And on top, I am super happy in paying my tax dollars and having these emergency workers do nothing, just be there with a utilization number of 0%. And that's a good thing. That's the only thing that I would rather waste money in having them do nothing, because that's what I want. And so I would have few trucks sitting idle in every location nationwide doing nothing at all whatsoever and feel happy about it. On the contrary, any other example you think of which is not an emergency nature will like to have a decent utilization, because it doesn't make sense to waste money. And in the case of emergency, it is actually important to overspend and keep the utilization number low. Because if the utilization is low, you have the agility to respond to emergency situations. If 4 out of 5 trucks are away doing business, your utilization number is 80%. You have only 1 truck left. And if 2 people call at that time, you are screwed, right? And so that's the problem you want to avoid. You want to keep the number low, meaning you want to over provision any infrastructure that may be needed in case of a V911 situation, and don't worry too much about utilization numbers as things go along. That is something that is a different type of case. It is a business situation which is related to emergency. And broadly speaking, these situations are rare. Not most businesses run into them. Most businesses will like to have a utilization number of 80 to 85%, and they feel happy about it. Sometimes people want to squeeze money out of it and take the utilization all the way to 100%, which may be a good thing, but it not necessarily is always a good thing. Utilization, can depend on the business situation. So people will use things like virtualization. Like, the reason virtualization came into play is primarily to help accomplish a decent utilization numbers. You can see that thing happen here. For example, you have a physical computer here, another physical computer here. This computer is utilized only 10%. This one utilized only 20%. You can put these 2 real machines into virtual machines on a different box and put VM number 1 here, VM number 2 here on the same physical box, and have this run this workload here, and have this run this workload here. And the overall utilization of the physical box, the real machine here, will be, say, about 30-35%, given the extra 5 for the VM overhead. And you can still accomplish the same result by cutting down 1 physical box altogether. And this concept is the virtualization, or rather it's called server consolidation. That's what people used to call server consolidation. And that's the origins of the discussion around using virtual machines as to put workloads together and put them in virtual machines on one physical box as opposed to two different boxes. And you are able to improve your utilization numbers a little bit beyond, and at the same time save money by not having to spend on two boxes. And that's a brief on this topic. Now, the same idea applies to a cloud setup, which you can, the benefit of using a cloud is simple in that you can have a scalable infrastructure put in place, which means you can actually put something like this in perspective. Let me go there and show it to you what I mean by an auto scaling group. So if you go to, say, any cloud, for example, this one is Amazon. Amazon is opening up, and you can have a instance that you start manually, or alternatively, what you can do is to start a group like this, auto scaling group. And what this group will do for us as we create is to, first of all, we need to have a template as to what you want to use as you grow out and shrink back. You need to specify exactly what type of machines that you need to start or stop as you grow and shrink. And so that is the idea of you have to provide a specific template. That template is called a launch configuration. Here you specify what configuration you want. And so you will build up your application server. It could be your processing server, like in case of the Netflix example we saw. Or it could be the case of a web server that is showing end users a collection of movies for them to select and watch from. It could be any other application that you want to run, that you want to create that application on one box first, and then use that box image to create a launch configuration. Once you have a launch configuration, you can then use that configuration to create a group where you define something like, where was that? Here. Where you not this, discard, open, cancel this one, open. Yeah. So you see here are 2 or 3 examples of auto scaling groups. One of them is here, where the idea is to use upload web servers. In this, the idea is to be able to use your processing pipeline servers. And here is the idea to use web servers. And 3 auto scaling groups help us in creating a scalable infrastructure. But when you're putting together a situation which actually deals with emergency infrastructure, you need to have the similar example that I mentioned here is you need to have 4 or 5 emergency trucks, T1, T2, T3, like that, provisioned already and doing nothing, sitting idle. And of course, you can tweak the number 4 and 5 and maybe less, maybe more, but have certain number already provisioned all the time, and then rely for the rest using an auto scaling group that will help you grow and shrink. And you also have to understand how much time does it take for an auto scaling group to kickstart a new instance as it grows, because that is also very, very sensitive in case of an emergency situation. People will not be willing to wait 10 minutes for a new machine to grow up and become a part of your web server infrastructure as it attempts to scale. People may not be willing to wait 5 to 10 minutes if it's an emergency situation. So those situations you have to accommodate by over provisioning to begin with. You cannot really rely on auto scaling, because this auto scaling infrastructure can take about 5 to 10 minutes depending on how you program it. And so that is something that you have to be aware of, and we will do examples on this auto scaling pretty soon. And that is the direction I'm heading next. So what I will like to do now is to describe what this really translates to in terms of a use case, and then actually play those cases. So I will now talk about, begin with the Amazon cloud, a idea known as cloud formation. This, by the way, is a service. Cloud formation is a service from Amazon. Pretty similar in concept, is also available from the Google Cloud and also available from the Microsoft Cloud. They also have it. We'll also play with those. And this idea of cloud formation is basically creating, or rather recreating, what you had already. Recreating what you had already. That's what it does. So if you have something created and you want to recreate the same exact stuff again, you can do that by click of a button. So you program a set of infrastructure and you put together something like, say, this or this. In any of these designs or layouts that you have for your given application scenario, you put things together and it becomes a complex setup that works for your setup. And now you want to tear the whole thing down and do it again. We have done this kind of an exercise in one previous example somewhere long ago. I think it was in, let me see where it was. We did that in a module 11 in cloud technologies, if I remember right, but I'll just point it out to you. So we did that one by hand. That was fairly elaborate and slow. And so we did this exercise here in cloud technologies. Let me point it out to you, which is, I think you will remember what I'm talking about, is this exercise. It goes into great detail about, where does that go? Where did that go? 11, no. Am I at a loss or something? I cannot find it properly. Yeah, there, module 11, this one. So this goes into detail about how do you put together a complete virtual private cloud step by step by clicking buttons on the Amazon console. You have done it. And once you have a point where you are feeling happy and comfortable with what you have created, you now want to destroy it and recreate what you had already. And that is programmable, by the way. You don't have to do these things over and over again by hand. And that is what these tools like CloudFormation will do. And other clouds also have similar products, by the way. But I'm just using that as an example to begin our discussion. So the idea that we are talking about is actually available right here in form of a service, which I would like to point out. From Amazon, they have, where did it go? Amazon has this service. If you click on the orange box, you will find it. It is called CloudFormation. It is somewhere down here. It's in the management tools section. And the second item in there is CloudFormation. So that's where we'll go and understand what it does. And it is kind of convoluted to think about what they do. And so it is not easy to grasp as to what is going on. And so they have these three things here that describe something, right? Let's go see what those three things are. So they describe the idea of creating a stack. They also have an idea of designing a template and then create a template. These three things, but what do they mean and how do we put that to use? And that is something that I would like to describe to you as to what these actions mean from a usage perspective. What is a stack? What is a template? And how do you create one? Right, so let's discuss this briefly. So I will go back here in my notepad and describe these ideas to you, because what we are really trying to accomplish is to recreate whatever we have created. Once by hand, we create something and then we take a picture, if you will, a snapshot. Like just basically take a picture of what we did and then using that picture, we are able to recreate exactly what we had before. And that is what we are going to discuss. So to begin with, in the cloud, you will put together whatever design that you have, and then you take a snapshot. So the word snapshot is not what they use. It's my word. I'm using the word, but they use the word template. So you basically, from an actual cloud, I should not use the word actual cloud, because actual cloud is a joke by Google. If you haven't seen that joke, there is a Google actual cloud video, which is kind of hilarious. If you haven't seen it, you should see Google actual cloud. And this is an April Fool's joke, by the way, but you should search on it, and play it on your own later. But this Google actual cloud platform is something of a joke, which is kind of funny, and that's why I bring it up. But that's not what I mean when I say actual cloud. I mean this kind of a cloud, right? The Amazon cloud, Google cloud, those kind of clouds, not actual cloud. Actual clouds are what we see in the sky, those clouds. So back here, the word actual is actually not cloud, not the right word. So just cloud, you create some design here, run some applications and make the customers happy. Once the customer is happy, you want to be able to create a template so that you know what you have already in your cloud. And this template is basically a JSON file. It takes a snapshot of exactly what you have put together. Once you have that template in your hand, what you can do at that time is you can afford to, of course, not make customers unhappy, but just keeping the customer aside, you can decide to delete your cloud and create a new instance of the same exact cloud again using the template. So that's the model that we are talking about. And it can be fairly elaborate as you go through an example template in form of a JSON file that we will create just a few minutes from now. And that is what we will end up doing, is to take a picture of a cloud, an actual implementation of some application somewhere, and take a snapshot in form of a file, and then use that file to apply back to the cloud and recreate whatever we had to begin with. Now, this use case has good business implications. The first biggest usage of this is that if you create something for yourself, and this is the thing you create here, say XYZ, and you want to give this thing to a colleague, to a friend, to another company, to a customer, it is very hard to give them unless you actually copy everything and walk over their office and then show them how to build it themselves. And that is hard. So that's why this idea of converting this infrastructure into a JSON file comes into play. This JSON template is what we are talking about, is called a cloud formation template. Once you have that template, you can put that in a Git repository and pass it along to a friend or a colleague. And now that the colleague has this Git repository and they have this xyz.json, what they can do is take that template, put that in a bucket, S3, and have it run CloudFormation tool, the same CloudFormation. And this CloudFormer is a tool that you have to run that will go to the bucket, read this JSON template, and create a cloud that will be exactly similar to what you had to begin with. And so what we are really doing is you create some blueprint, some architecture, some design, some application set that runs for you, and you're happy about using it, and you want to give it to a friend. You basically do a JSON route and pass that in a Git repository to another person, and they can form the same cloud setup. and they can go do the same thing again. They can modify this, maybe call it WXYZ, call it something different, change it again, and create another JSON template, WXYZ.json, a different file, slightly different from this original file with his or her changes included here in the actual cloud and captured in form of this different file, and that you can then iterate on it. You can improve upon it collaboratively. And that collaborative improvement on a infrastructure design for a given application architecture is how this particular tool is used. And so if you decide that you have to prepare a new application for a new customer that you have already, so you have this X customer already to begin with, or I should call it A customer A already, and you are using the XYZ JSON for that customer, and you now have a separate customer, the B customer comes along, and they want exactly the same thing. You can create a separate identical infrastructure, an identical architecture for an identical application, but for a different customer very, very easily by reusing this JSON file and applying it again in the context of this same cloud, maybe different company, different account, or the customer's Amazon account, and have them play this same template on their cloud to create your architecture for your application in their account and have them benefit from what you provide to them with ease. So that's the benefit, and that's the use case of what this discussion is. Now, having understood these use patterns, let's see how these things actually work. So in order for us to have a cloud architecture put together for a given application, we need that on one hand to begin with, in order for us to create a JSON. So this is what I call capture step. You capture whatever you have, your architecture you have, you capture it, put that in a file, and that file goes in a bucket, S3 bucket. That's the capture. The next action is kind of the other way. Now this action, I should actually draw it like this. So this action begins with a JSON that is in a bucket, and you apply, or rather the word Amazon uses is form, cloud former, not the word apply. So the cloud former tool will run against a JSON file and will prepare the cloud with your architecture in place. So this cloud former tool expects a input in form of a JSON file. And that is what we need to be able to use. If you want to create some architecture in the Amazon cloud, you have to run this tool. This tool expects a JSON. Now, a strange twist to this, that this cloud former itself runs in your cloud. So in the same cloud, you will have the cloud former tool running on a separate box in your cloud, which doesn't count itself. So when you take a picture, like a capture, you have to run the cloud former here and have it capture whatever you're trying to attempt to capture. And that's the scenario that you will see. Now, let's go to Amazon's website and see what they describe, how they describe what these ideas are. So here, the last item in this three blue buttons we have, the last item is to create a template from your existing resources. So that is when you have a set of resources that you can click the launch the cloud former, that will go and look at what you have in your cloud account, will take an inventory, and at the end will dump a JSON file in a bucket for you. That's the play that you will see this thing running. But when you don't have anything to begin with, you need to create. And so you can create a new stack. So essentially it describes create a stack It allows you to quickly and easily deploy your infrastructure. You can use one of the templates that we provide. So they give you some starter endpoints, starter template solutions for quickly starting applications. For example, they give you a WordPress or Drupal and many other examples. So they will give you some ready-made templates that we will begin using right now and apply that to our cloud in the Oregon region right here. And we will say, let's play with it. So I'm going to click the blue button and it says, you provide a template. So you say, I will upload my template right here. So I need to give my file, but I don't have a file, a template to give. So I cannot choose this option quite yet because I don't have a JSON to give. So I have to get some JSON somewhere that might have in a bucket. So I'll say, okay, let me go and grab it from a bucket that I already have in form of a S3 bucket. I want to provide that S3 bucket endpoint right here. That's another way to provide them a template. But in our example, we don't have any. So we have to select a ready-made template just to play with it, to understand what we are dealing with. And so we'll select a sample template. And here are some samples available. They're giving us some few examples. Single instance samples, multiple availability zone samples, Windows samples, tools, and more samples. And so we'll begin with any of these. Let's begin with something simple. Say, for example, WordPress blog, single instance. So we'll just select that template and see what they give us. So we have selected a sample template for a WordPress blog, and we'll say, go. So I click the next button. It says, give me a name for this thing. I'll say Cloud Genius WordPress stack. Now it's asking me to provide a database name, provide a database password. My database password is 123. And my database root password is also 123. My database user is, I need to remember these things. The username is user. Okay, so I have to make sure that I remember the password I gave here was 123. The root password I gave is also 123. The database user I'm giving is USER, lowercase. And I am going to ask it to proceed forward with the next step. And next. And then it is asking me to read. So it is basically telling me that this template will create an Amazon EC2 instance. You will be billed for it. And I know it's going to cost me money. And that's okay. But this is the template that they have given us. You can read that XML the JSON template, which is this JSON file, as you can see. It's fairly long. It describes what exactly will happen. And you can, I'll paste a link for you so you can read it yourself also. Let me grab that link. So this link I'll paste in Slack chat so you can have a look at it later. But that link is essentially what I am using as an example to create a stack, a cloud reference implementation. And that is what will happen when I click the next button right there. And the create button is right there. So I will use that. But before I do, I will like to place a link for you to review the JSON template that I am going to play in CloudFormation tool in the Amazon cloud right now. So that is what I'm waiting for it to paste in the right spot before I proceed. So you can take a look at the JSON as I play it here in the CloudFormer tool. So come on, Slack. See, this is the problem when utilization is high, that Slack doesn't respond quickly enough, right? So Slack did not start properly because the utilization is quite heavy on this machine right now. As you can see, 62%, 56%. And that is the reason why when the machine is busy, that Slack doesn't start quickly enough. So if there is an emergency, your machines may not respond quickly enough. That's the exact scenario that I just showed you in real life. Slack took time to start, although it's a small application. Now, having given you that link in the JSON file that I'm using in this CloudFormer stack, I am going to read the details, the database name, the root passwords are 123, username is USER. and I will proceed to create. When I create, it says template validation error, parameter DB password failed to satisfy the constraint, must contain only alphanumeric characters. What did I type in there? Alphanumeric. Okay, alpha is not there. I see. So we have to go and modify the password to make it a little bit more complex, which is kind of lame, but that's what we're dealing with, right? They're forcing us to make the password complex. Okay, I will make it complex, but then it becomes difficult for me to remember. Okay, whatever, I'll remember this. So I'm typing a difficult password and erasing that. So 2 times I have to give a password. These are 2 different passwords. One is a database password and the other one is a database root password. And I have typed alphanumeric, and I will proceed forward with the next step. And next step again. And let's see if it lets us create. And I hope it did. So it says creation in progress. You can see the logs here as it goes ahead. It takes about 2 minutes for it to finish whatever it is doing. You can see the output. Once it is ready, the output will become available here. And events, you can watch as to what is going on. And looks like it already rolled back. It did not like it or what? It says parameter validation failed. Parameter value for parameter key name. Oh, we forgot to give key name, it seems. Okay, it did not ask us for a key name. Let's refresh one more time. I don't recall it asking for a key name that I did not give. It rolled back the whole thing. So it did not go forward complaining, saying that I did not give a key name. It says right there, parameter validation failed. Parameter value for parameter key name does not exist. Rollback requested. Fine. So we'll go do it again. We'll say, show me the place where I need to give a key name. And the key name that I have in Oregon's cloud is, where is my key name? I think it is ID_RSA. So that key name I have to give. So I'll go back to CloudFormation and begin to create a new stack. So create stack, select a template. So I'll say WordPress and I'll proceed. And then I'll give it a password. The password, we should be complex. And the username is USER. USER is the username. And then key name, you have to give here ID_RSA, which I did not. I think I forgot to give it, this key name. It was this key I needed to select, and then I proceed forward. And then I go next. And then I proceed ahead. Say create. And this should now start the stack. This stack should start. It is getting creation in progress. This rollback has finished, so I can get rid of it. I hope I can delete that stack completely. The one that did not have the key name in place, I'm deleting it right now. And this stack is in progress. You can see events happening as we speak. And it tells me that creation is complete. So quick. That would be impressive. So let's see output. Do we have an output? No. Well, it is creation in progress, so not complete. Some specific action, security group action got completed. So it created a security group for us. So you can notice that it is doing a variety of things as it goes along in constructing whatever we may need for our specific application example constructed in our EC2 cloud in the Oregon region, where you will see a machine running right there. New machine starts up, and this will basically have a bunch of characteristics defined in this JSON. This JSON defines a whole lot of things for us, and we can see that as we expand it. You can see what it is going to do, and I can read it for you. So it's first thing expects a key name right there. And then it asks you to select an instance type. The default value was T2 small. So we expect to have this machine a T2 small, which is what it is. Next, we have a SSH location. So that location as to where you can connect to the box. And the default value is 0000. Basically, from anywhere on the internet, it is allowing to connect to that particular box. And that you can specify to be narrow to just your IP address, which will be allowed to connect. If you like, you can change that in the template as we go. The DB name is WordPress DB. There is a constraint that they have put together. The constraint allowed pattern is specified like this. Basically, it means begins with a letter and contains only alphanumeric. Here you have a DB user. It is no echo, meaning it doesn't show to the end user as it types. There's a DB password expected, DB root password expected. There are some mappings here. So for example, for T2 small, the architecture used is hardware virtual machine 64-bit type. So the architecture instance type to architecture match is mapping is called out in this JSON segment. You will see that AWS instance type to NAT architecture is also called out for T2 small to be NAT HVM64. Similarly, if you keep scrolling down, you will find that AWS region architecture to AMI matching mapping in my US West 2 Oregon region. The machine image for HVM is this, and the AMI number is ending in 611, B611. So that AMI number, we can actually compare and match it right here. You can see that this T2 micro actually uses an AMI number, which is somewhere here in the sheet of paper you can find. And it is that same number you can see at the end here, 611. The same AMI was used, which is specified right here in this segment, which applies to US West 2, HVM64. The machine image to be used is this number. And scroll. And you will have a security group created. That security group will allow port traffic from port number 80 and also allow from port number 22 from a restricted SSH location. But port number 80 traffic is open to the public internet from anywhere on the internet you can see. Similarly, this metadata is being called out, meaning at the end of the run, you have to do these things, which is basically to create a owner group of a set of stacks in that particular script that you want to initiate. AWS bin CloudFormation initialize. That is also defined. You will also see that the install of WordPress happen. You will have some packages loaded up with PHP, PHP MySQL Server development and libraries and HTTP daemon. You will have the source of WordPress come down from this URL, which is where WordPress is sitting. The software sits in that location, so it is going to grab it from that source. And you want to create WP config, which is a file that stores your DB name, DB user, DB password, and at the end, you want to enable HTTPD is running, MySQLD is running, and that is almost to the end of our configuration here. So WordPress configuration is basically you're setting up MySQL root password, you're creating a database with your chosen variable references, you're configuring WordPress, and then you're setting up other things here, which are image ID, instance type, security group, key name that you have, the key name that we have provided, ID_RSA. And at the end, we will have an output. The output will be a value that is basically giving us an HTTP endpoint for the web server /WordPress. That's where we will have our WordPress site. So this output we expect to see in the CloudFormation output tab. So if you go back to CloudFormation, you should see that result right there. So if you go CloudFormation and look at our stack that we tried to create, it should report completion and create complete. And you can see that this stack has an output value that is on this particular stack. It gives us a output value, and the output value is a website URL, and that is the result we obtained from our CloudFormation creation step. It used this template, this JSON file, as an example to begin with. And Amazon has given a variety of examples as they start, as people start using this method of constructing a stack that represents a given architecture for a given application. This example was a very, very simple one, just one box that created this endpoint. And that endpoint is what I want to visit right now. So I click on that, and what do I see? WordPress. So we'll go give it a title and a username and a password and email address and install. And there we have WordPress. So here is the password typed in, and we are logged in, and we see WordPress running. So from that perspective, it is simple. But the thing to remember here is that we constructed this using a JSON file. This JSON file that was sitting in a bucket that was given to us as an example starting point, Amazon gave it to us. We just used this tool and applied that to the cloud to create the architecture we wanted in fairly simple steps. That's the process to build a cloud scenario, a cloud solution for a given setup based on whatever you call out here in the JSON. You can construct JSON by hand by manually typing in an editor. It can be boring, can be difficult somewhat. However, Amazon also gives us the tool to create JSON. So we have done this part already right now. And we can see that it will allow us to create a JSON for ourselves like this, based on whatever we have here. So here in our cloud, let's figure out what do we have. So we will go to our Amazon account. We'll see that we have this site running in one box in Oregon region in the EC2 section. You see that that's the box. That's what we have right now in this account in the Oregon region. So it's very, very simple. But I want to make a change. So in that running instance I would like to make some modification, very, very simple, trivial modification. Just to capture that modification is what I want to do is expand the security groups that we have. So the security group that we currently are running is, let's go focus on that. We don't know which one is this out of these. So I go back to the dashboard, pick up the correct instance, and in that instance, I will select it. And once it is selected, it will tell me which security group it is actually using, so we can view it. And it tells us that the security groups currently active are port number 80 and port number 22. And what I want to do is make a change in this design, and I want to make it HTTPS. So I'll open that particular security group and say you allow edit HTTPS like this. So very simple change I'm introducing here to allow anywhere access to HTTPS, and I'll say save. So I just made a change to my design, slight change. And I want to capture that change in a JSON file using their tooling. So here, what I want to be able to do is, now that I have some cloud, which is slightly different from the one that they gave me before, and I want to capture this in a JSON. And the changes I have made, by the way, I know very sure, is this port I opened up for HTTPS access. And that's a design change I introduced in my design because I want to make my site secure. I will place an SSL certificate here eventually. And for that preparation, I want to expand my security group to open up this port. And I'm going to capture this design idea into a JSON file, which requires us to run another tool to capture this thing, this design, and produce this output. I want to produce that output, which requires running a tool. And that tool needs to run on some computer. And that some computer needs to be in your account in that cloud, in the Amazon cloud. It needs to be right here. Another box runs the tool right here. This tool will then take a look at whatever else you have in your cloud and then create a JSON and save it in your bucket. And then done. That's what needs to happen. So this tool that you need to run in another box requires another template, another JSON, which is the convoluted part that I'm describing, by the way. The part that is kind of hard to understand when you do it first time is to have a cloud and create a JSON. I need to have a machine here, which I need to create with another JSON first, and then run the tool here on this box, which will then produce this. So that's the convoluted part. Why do I need a JSON to create a JSON? That's the part that most people don't understand, but I just told you why it does. We will use this JSON, which is specifically the tool JSON. And this is going to be our JSON with port number 443 open. That's what you will see at the end, but we are going to create this tool and run it in a box in our own cloud by using a tool JSON. And where is this tool JSON? Amazon will give it to us. So we'll go find it. We'll run the tool JSON to construct the tool in a box in our own cloud and then check it out. That tool will then look at our cloud and produce this, our JSON, as we go along. So we'll go back to our CloudFormation. So orange box, and look at CloudFormation again. And here there are these three blue buttons that are not there anymore because we have an active stack that is created, but they are hiding here. So where are those? Oh, they have changed something apparently. I think they call it exports these days, probably. I'm just going to figure out what this export is. Probably that's what it is. No. Where is the button? I want to capture my own JSON, please. So this stack that I have running, action, design template. No. Let me see where this thing is. They changed the UI a little bit. I'm trying to figure out where it is. There is a place to start a tool, and that's what I'm trying to get to. So give me a second. I'll find out where it is. They must have moved it somewhere. Leave. So CloudFormation, again at the very top. I'll maybe change my region to see a different view of it. That might give us a quick way to go there. And here we have. So this is the tool that we have to really run. Create a template from your existing resources. That's how I am able to actually change the region to go to the tool. I was in Oregon and this screen did not pop up, but I want to run CloudFormer and I want to choose the correct region again. So what I'm doing is cheating a little bit to get to the tool and then switch back to Oregon. That's how I was able to get to this point, which is where I want. And I want to create a CloudFormer tool and I want to run it. Hold on. I want to run that tool in, let me simplify this for you. I think I may have confused you by jumping around in a variety of locations. So I want to recap this. I was in Oregon. If you go to CloudFormation, in stacks, you should see the one stack that I have running there. What I want to do is capture, and that stack has updated, by the way. So I want to maybe this is the new tool that they have added. Create a change set for current stack. No. Stacks. Create stack. No, there has to be a place to go like this. Let me show you what I'm talking about. I'm still not clear on where exactly that tool creation step is hiding here. So I will do a Google search and figure out where the tool is. The tool is probably hiding CloudFormer US West 2. That should give us. The following collection of AWS CloudFormation sample templates are for the US West 2 region. Man, this is crazy. They changed something on me. Hold on. I'll begin from the top, and I'll figure out there has to be a place where this is hiding in plain sight. So I'll begin from the top, CloudFormation, and in Oregon region, there has to be a way to capture my stack. Where is that? Okay, I will then use the backdoor like I was attempting to do. So I could not find it. There should be a button here that exposes it to me readily, but I don't see it. So the backdoor I'm going to use is actually trick it to show me that button. So what I'm doing is changing the region here, go into another location, say Virginia, for example, and I will run the CloudFormer tool in Virginia. So to create that tool, I have to use this CloudFormer tool, which I will kickstart. That button is not visible once you have a stack created. I don't know why they don't show it to us, but that's what I'm noticing. So I work around that problem by selecting Virginia location as another location where I can go. And there I'm able to find that button that allows me to create a template from our existing resources, which requires us to bootstrap a net new machine, which will become a place to run the CloudFormer code, the tool. The tool needs to be created using a specific template that is called the CloudFormer template, which is available in this bucket right here in US East 1. And that is the CloudFormer template. So I'm going to attempt a hack just like this. What I will do is modify that US West 1, so make it US West 2. And I am assuming that's the right hack. So what I just did here, pretty same thing, except I'm doing a slight hack. What I'm doing is opening up this link, which I just modified, and all I did was a change. Instead of West East 1, I made it West 2 to correspond to the Oregon Cloud CloudFormer template. And I'm assuming this is the right location, and I will test it by opening it up in a browser. And it seems to be not available. It says it must be addressed using the specified endpoints. Please send all future requests. Okay, so the endpoint is different. You have to hack it slightly differently. Cloud formation templates, US West 2, S3, Amazon.com. So I'll go modify it. Like this. Really, really hacky. And it's not exist, doesn't exist. Okay, then a Google search. US West 2 Cloud Former template. Show it to me, please. You cannot hide away from me like this. US West 2 Cloud Formation template. This is so hokey. This is why I don't like to use these custom company specific solutions, because they are sometimes not maintained properly, or the documentation is missing, or something or the other happens like this. That's why I use Terraform, like I mentioned earlier. Terraform is a third-party open source tool which is available on GitHub, so you can play with it anytime you feel like and modify the way you want. Let's see if this step doesn't work or doesn't get me to the right spot. I will attempt to run it in the East Coast location without any change and hope it works. So that's what I'm hoping. I will stick to the Virginia location and use a tool in Virginia to operate in my Oregon cloud. I hope that will work. I'm assuming. So I'm not hacking anything, just selecting Virginia, starting the CloudFormer in Virginia, and using the existing sample that they're giving me as is without no changes, and go next. And here I'm going to say create a CloudFormer stack, and my password I'm going to select. It should be complex, so I'm going to select a complex password, and my username is USER, and I'm going to use an existing default VPC. So it will be the default VPC. And I'm suspecting that this will actually create a problem because we are in Virginia and it will be unable to see what I have in the Oregon cloud. That's what my gut tells me, but I'm still going to run it. And so here I'm going to go forward with it and say, produce a tool that will run in the East Coast to look at my West Coast cloud, which is very likely to be blind. It probably cannot see unless Amazon has improved. And so I acknowledge and I proceed to create. This will create a tool to run CloudFormer stack. So you are looking at Virginia location, and the CloudFormer tool itself is getting created. If you go back to Oregon region, you will find that I have a WordPress running there through the CloudFormer tool, that from a ready-made template that we have, we have modified the cloud infrastructure itself, and we have modified it to include our HTTPS port. So slight change I want to make, I want to capture that in form of a JSON template, for which I need to run a tool which I'm running in a different coast, Virginia. And I'm very, very sure that this will fail to see what we have in the Oregon cloud, but we'll still give it a shot. If it actually is able to see the Oregon cloud sitting in Virginia, I will be happy to see that, because that will be a sign of progress for Amazon's East Coast to see Amazon's West Coast. Good progress. But I'm not super optimistic as this will actually succeed. But if it does, great. I still struggle in my Oregon cloud to start the CloudFormer template, because I cannot, for the sake of my searches, locate where that thing is. So by the way, we have this CloudFormer tool getting created in Virginia. In the meanwhile, I'm trying to explore further to see where we can actually find a CloudFormer tool and run it right here in Oregon. That's what I'm looking around to see where that thing is. And I hope I will find it. If not, I will ask somebody in Amazon to help me locate that because I cannot find it. So in here, maybe? No. Actions, no. Create stack, maybe that. Then you have to specify this template. And oh, they're hiding. I found it finally. Okay, they're hiding here. So you have to create a sample template, which is called a former. Wow, that's where it is hiding. So I hope you understand. They move around stuff and they hide the sample template to create a cloud former tool in this location right here, which is where they have relocated apparently. That's what I think I just found. So what I'm going to do is start a former tool in the Oregon cloud right here. This tool I will create and give it a name. This is my former tool in Oregon. And I will give it a password. I hope I typed it right. And I will give it a username called user. And I will select an existing default VPC and go next. And there I will go next. And then I will say, I acknowledge, and I will create. So now I have two tools running in two different regions, and I'm able to locate this cloud former tool in Oregon by creating a stack and selecting a template, which is kind of hiding below in this location. That is where it seems to be hiding, which is how Amazon tricked me. But we'll go look at what Virginia is doing right now, and we will find that it may have finished creating the tool set for us. So we will see, Virginia, what are you doing? Show me what you got and show me my stacks that you were running for me. It is still creation in progress. You can see some events. The events are happening, and this tool will basically finish creating at some point. At that time, we will have a tool running in Virginia. Similarly, we have another tool created in the Oregon region. So we'll go to that region and find out what we got. And by the way, this will be a good test for us to find out if the East Coast tool can actually see the West Coast cloud or not. That's what we'll be able to see that momentarily as soon as these creations finish. So this tool is running in Oregon. It is creation in progress. The WordPress stack is already created and complete and running. And we are waiting for these guys to finish. The way they hid that thing was crazy. Crazy as in, maybe it makes sense. Maybe it makes sense. Maybe it makes sense in that it's a template and you're hiding it here. That's a good way to think. But then I was expecting, because the previous behavior in this website was that there was a separate button called out specifically, just like say, I'm going to show it to you. You saw it. Just going to show it to you again. The third button from the three selections that we have here in CloudFormation in a fresh new region like Ohio, will show it to you. 3 buttons. And the third one is the one that we want, is to create a template from existing resources, which basically is the purpose of a CloudFormer tool. And that button is hiding in a create stack step in a template right there. Crazy. But I found it finally. So let's see if these creations have finished. Come on, CloudFormation, show me the stacks. And it is in progress. And what about East Coast? It's just one box taking so much time. I don't know why it takes so long. It's the tool that you want to start quickly for me, and you're taking so much time to create it. Whatever. Okay, so while it does, let's look at other companies as to how they do it. So like CloudFormation, what does Azure do? So we'll ask this question to Google. They'll tell us the answer. And the answer is right here. And is there an equivalent of AWS Cloud Formation in Azure? The answer is yes. It is called Azure Resource Manager. Pretty similar to what you saw before is what you have here. There is an idea of a Azure Resource Manager template, which is similar to the idea of Cloud Formation template. And what it does is basically captures. And so in Azure Resource Manager templates, the idea is you can get a JSON format output. Cloud Formation, you can get a JSON as well as YAML. You can select the two formats. And structurally, they're very, very similar. Documentation, both of them have somewhat useful documentation. You can, basically compare and contrast these guys, but the best way to see these things in action is to not read here, but go straight to manage.azure.com. Is it manage.azure.com? Manage Windows Azure. Okay, manage.windows Azure. I thought they changed the name from Windows Azure to just Azure, but the domain did not change, it seems, which is how Microsoft functions. Slow. So you're looking at Windows Azure, which is actually Microsoft Azure, but the website is still Windows Azure. And here you will eventually find it, the thing known as Azure, Azure Resource Manager, right? Azure Resource Manager. That thing you will eventually find in this website. And as usual, it is a struggle to find it. You will not find it here in one shot. And I bet money that you will not find it, because that's how Azure is set up, is cryptic. So maybe in the new portal they will have it.
Yeah, I think it's in the new portal. If you go to portal.azure.com, it's
correct.
Yeah.
Correct. And that's what I'm heading right now. And so what happens is, these companies will create their own websites based on what the people are thinking, and the people who are developers, how they think. That's how they develop. They don't actually ask the customer too much about Azure Resource Manager and where would you find it, and somewhere here you will actually find it. There should be a place to find Azure Resource Manager. More services, all resources. We'll get to it, but I think our machines are ready on the other cloud, so we'll get there first. Our machines, the tools that create a CloudFormer tool is ready in Virginia, right here. It seems creation completed, which means our output should have a result. And so this machine that you're looking at here is a Virginia location tool. Similarly, in our Oregon location, we should have also the thing complete by now, I hope. And we will see both of them, and we'll also be able to examine whether this also created complete successfully. So we'll be able to run both these tools one at a time, beginning with the Virginia tool, and we want to see if it can inspect and prepare a JSON for our Oregon cloud. That's what I want to do first. So I'll go back to Virginia, and in that location, I will identify our CloudFormer tool and say that give me the output. And so I see the output right here, and I will open it up in a website, and it says, you have a bad certificate. And I said, absolutely. There should not be a bad certificate here, but they should give us a proper certificate, but apparently not. So open it up, please. Okay, no. So I'm going to go HTTP without the S, but it goes back to HTTPS, which is crazy and expected. but they should provide proper certificates. They did not apparently provide proper certificates. So we'll try another browser. See if the other browser is able to open that tool in the Oregon location right here. Click. Open it up, please. Come on. So you create a tool for me and don't even allow to open it up? How nice. How fancy. Okay, one more try. In incognito browser, incognito window, paste the link and put it, let it go. So incognito window, downloading proxy script, connecting. Come on. No. This is lame. Lame as in I cannot describe how lame this is. But it is really, really lame. Next, we'll try the other cloud, Oregon Cloud, and see if that one opens up, I hope. So Oregon Cloud is, what did it say? I'm in Oregon. I want to load my stacks. So please show it to me. Yes. So there is the Oregon Cloud tool. I want to see the output, and the output is right here. I will copy that output, copy link address, paste it in Slack chat. Here we go. And see if you guys can open it. Tell me if you can open it. I'm going to also open it right here in this window and see what happens. And it is asking me for a certificate. I don't know why, but I'm going to give it the second certificate this time and see it work. And now it seems to respond by saying that my certificate is bad. And I say, fine, I know what you're doing. So I'll say unsafe and I'll go proceed forward. And now it asks me for a password. Okay, now I have my password. By the way, this is the Oregon machine. I want to play with the other machine first, right? So I will leave this one alone. I'll go back to the East Coast region, grab that machine URL, the tool that is running right now. I will grab that first, play with that one first before I type my password here. Because I want to test this, whether the Virginia CloudFormer tool can actually open this East Coast machine, can open the West Coast cloud or not. So I will go unsafe, type in my password on the East Coast machine. And here is the first time you will get to see the tool running in the East Coast and helping us. Oh, it does. It does actually let you select the region you want to go and create a template. So it does actually is able to see. So what I'm looking at is a tool running in the East Coast. Here is your East Coast machine. And this machine is the West Coast machine, US West 2. I'm not using this one. I am using where is the East Coast machine? Here. I'm using the East Coast machine. And in that machine, I'm saying that you go to the Oregon Cloud and there you create a template. So this East Coast machine is going to analyze the account in the West Coast, US West 2 Oregon region, and take an inventory of what do I have in my account. And then ask me to select what I want to keep track of. And at the end of the process, it will dump a JSON in a bucket. So it is going to study right now in the Oregon Cloud, examine what I have, and ask me to select what I want to keep, unselect what I don't want to keep, and then give me a file output. That's what I'm expecting this analysis to finish like. And it is still doing the analysis right now. So it says, okay, give me a description. So this description is my modified WordPress stack. And it says, you know what, just select everything I have there and continue. So there are no hosted zones in the DNS, which I don't have. So I proceed next. Do I have a VPC? Yes, I have 2 of them. I don't know which one I want to keep. So I have to select one of the VPCs, not both. I have 2 VPCs, it seems. So I just go and select and identify the right VPC I want to keep and use in my Oregon region. I have 2 VPCs, so I want to select the correct one and unselect the other one. That's a manual step. When you have multiple VPCs, you run into that problem. So you have to go VPC and identify which VPC is actually in use. And I think the best way to actually identify this is to ask the machine. So we have 2 VPCs. We'll go to the machine itself, ask the machine, where are you located? It will give us the appropriate VPC number. We'll keep that one in the tool and unselect the other one. So the machine is populating up. In EC2, you will find that machine that runs WordPress. And by the way, you will also find another machine that runs the tool. These 2 tools we are running, one in Oregon and one in your East Coast. So you will see the Oregon tool here, and you will also see WordPress. So one of them is WordPress, the other one is your tool. But which one is which? Or I need to make sure that I clarify that I don't want to capture the tool here. So this B611, if I remember, is the machine image that I wanted. And you can also tell this by the age of the machine. So how long it has been running. The launch time is 6:06, whereas this other tool was later. So it's 6:37. So this machine is actually the former tool. And this machine is your actual useful machine running WordPress. And so in here, you can ask what VPC ID are you belonging to? And so it is 7901 echo. So that you want to keep in the tool. You want to see that this tool actually keeps the 7901 and not the other one. Then you continue forward and you will get to select other aspects, such as which subnets you want to keep. So I'll select all these 3. Similarly, there is an internet gateway created. We have to keep that gateway. There are no customer gateways, no VPN gateways. There are some DHCP options. You want to keep them. No VPN connections, no peering connections. So we'll proceed forward. Then it comes to VPC security. There are 2 network ACLs and 2 route tables. We have to keep both of them. And next up is the network segment, which will pop up right here. We have some CloudFront distributions, but in our design, we are not actually using any of these. So we will unselect all of them. These distributions belong to other things that I have in other examples that I'm running in my cloud. So I want to unselect them. I will go select forward, continue forward, and I'm basically walking through everything I have in my Oregon cloud and making sure that I select what I want to keep in the template and unselect what I do not want to keep as I go forward. And here we have 2 EC2 instances. I want to keep only one of them. And I know which one I want to keep. I want to keep the WordPress instance, which is the instance ID ending in E47F. So I will keep the E47F instance and not this one, which is a tool. I don't want to capture the tool itself. So no to you, like this. And I proceed forward. I don't have any need to select any storage. So these buckets are actually independent other projects. So I'm unselecting all of them. And I proceed forward. And like that, step by step, I don't have any RDS database needed here. So I will unselect all of them, remove all of them, and proceed. These SNS topics are also unnecessary. So I will proceed. I have security groups that I want to keep, and I want to select the correct security group that I have in my example, which I have changed to include 443. By the way, this change I made, I want to keep this particular security group ending in 3E47F. Sorry, this number is R4V. That number I want to keep, this number. And so I will keep that number ending in R4V. And that is the group security group I want to keep. which is this number right here, R4V, and not these guys. This is the tool related group, and this is the web server related group. So I want to keep that one. I have RDS security groups, which I don't need. I have SNS topics, which I don't need. I have bucket policies which I don't need. And then I proceed forward. And that is how you collect all the aspects that you need to keep in your cloud. And you get a summary at the end. This is what you want to capture. And you say, yes, this looks good. And I want to then create the next step, which is to dump a JSON in a bucket. So you can dump the JSON by clicking the save button, and it saves in your bucket. So you probably saw that it was going to place that thing. I think it generated an error because I went back. But in my S3 bucket, you should be able to find that I now have a JSON template, which is in my S3. So I'll go S3. In orange box, go to S3, which is a storage solution. So right here, and somewhere in here, you will find a new bucket, which contains the JSON that I expect. And you will probably expect to see a new bucket pop up. I will wait for it to pop here. And the bucket that was created, just the latest bucket was what? Where did it go? It should have, it probably told us where it's going to put that bucket, but I did not pay attention to the bucket where it was going, which is lame. And now it is causing errors. This is crazy. Okay, we'll go back to the front page and see if it still responds or still wants to talk to us or not. And let's go to the summary section, please. And it is slow. Wow. But you will find once you use a tool called Terraform that these issues that you're dealing with will completely go away, because you will be dealing with a Git repository and the command line on your own local laptop. And it will operate on the cloud as you like, and it will create a complete stack, complete architecture design of your choice that you specify in your Git repo. It will just play a design, if you will, and implement that design in the context of a given cloud. And that example we will run momentarily after we finish this company specific tools, which I actually do not like. The reason I do not like is that if you use this CloudFormer tool, then you are stuck with this tool. I mean, this company, this Amazon company, you're stuck with them. And I don't want to getting stuck with any one company. I don't like that. So it says you have to choose a bucket, it seems. And it doesn't give me a drop down. How nice. Well, we'll give this a bye-bye and jump to the other location we have here. This other tool, I hope, will give us the answer. So we are going to type the password here. This other tool is running in my Oregon cloud. I'm going to log in and then repeat the same steps slowly but steadily. And that is quite boring to wait, but that's what I'm doing. Wait. So this thing is making us wait. It is analyzing our account. Okay, here is my description. And I'm going to proceed and proceed and proceed. I'm deselecting the other VPC I don't need. And proceed. And proceed. And unselect these guys. And this is the machine image I want, the only one I have. The other one is the tool. So tool doesn't detect itself, which is a nice thing. As you can see, this is the tool running, and the tool did not detect itself, which is the right behavior. And that's why you see only one instance, which is what you see right there. And I proceed forward. I don't need these RDS situations. I have no application services I want to capture. I want to capture my security group, and no SNS topics, and no bucket policies, and no RDS group. And then I continue. And then in the summary, I see the summary, then I continue and carefully hope to select a name of a bucket, which is this bucket called Cloud Genius Code bucket in the US West 2 region. That's where I want to drop it. And the template will be called OMG. Hope it works. Hope it works template. OMG, hope it works template. And I save that template in this bucket I have. So I save. Great. Thank you. Now show me, please. So my template, my bucket is Cloud Genius Code. And I should see a OMG hope it works template right there. And I can download it like that. Of course, access denied. And so go back a step and click the download button. Come on, like that, download. And there it comes, my file. I want to dump it in your downloads folder and save it and open it up for us to read. Come on. So downloads folder, and there is the OMG hope it works file. I want to right click and open with Notepad. Atom, good. So there we go. Atom will open it properly. Come on, Atom, start. What? There we go. So we have a new template that came down from our CloudFormer tool that actually describes this. And that template, as you can see, let me make room here and get rid of this, and the welcome guide. And then this is our template. Now here in the template, you can see the critical thing that I was expecting to see, which is the port 443. So I'm going to search for it, 443. Show it to me, please. Command Control F. I'm searching. Come on, searching. I'll just search manually, visually. There it is. I type 443 and then boom, here it goes. So you can see that the security group for ingress has been expanded to include 443 as a port. And this is an extension of the existing template that we applied. The existing template had only port number 80 and 22. We expanded that to include a change in the design to include 443. We did that for real, for actual in the cloud right there. We went to the cloud and actually modified the security group. Then we came ahead and used the tool here to create a template, and the tool correctly captured that JSON file, which is now sitting in my laptop, that looks like this, and you can see it in line number 287, 288. It defines the change that I incorporated in the design, and it captured that change in my template, which means I can now give it to my friends like this. I can say, you know what, hey friends, take this template that I just modified. It is exactly how I have running in my cloud. So I'm going to give it to you, and that you can run it in your cloud as well. And so here is that template, and please take. So I just gave it to you in Slack chat, and you can give it to in any other fashion, but there's the template right here. And what you can do, and I think what you should do, is an exercise. The exercise basically is take this template that you're looking at in Slack chat and create your own setup that exactly matches my setup. And that gives you the idea of reproducibility of a given cloud architecture or a given design for a given application in your context as opposed to my context. So we are basically removing a context of a person or a company or a project away from the picture and extracting very relevant components in form of a JSON file that is reproducible in another location with you, with a customer, with another company, things like that. And that's the core idea behind these toolings, to be able to craft, take a snapshot of what your design looks like and then capture it in form of a Git repository, use it to other products, other services, other customers, or maybe give it to other companies and have them reproduce exactly what you have. And that's what this tool does. What we will do next is next time, which is when we meet again. It will be Monday, I think. Yeah, Monday, no, Monday is a holiday, is it? Yeah, I think Monday is a break day for us.
Yep.
Right? Did I not confuse you? I hope I did not confuse anybody. I just want to make sure I double check. So I'm going to the front page of the website. And on that website, you should see exact dates as to what is the next session. And that next session should be not Monday, because Monday is Memorial Day, it seems. And therefore, the next session will be on 31st. So after 26, the next date is 31, which is a Wednesday. And we will meet again the same way at 4 o'clock Pacific time, 7 o'clock Eastern time on 31st of May on Wednesday. And I have also put dates here for the next run of the bootcamp, which is in September. So you can see that the next bootcamp dates are published now here: cloud technologies, DevOps, and architecture. I just want you to know, not that you care, but just want you to know that we have put dates here for the next set of bootcamp sessions, which is far, far out in September. I'm taking summer off. So I'm not doing anything, at least not running a bootcamp until September. That's what my plan is. And just want you to know. But I will be here until this bootcamp finishes. So I'm not going anywhere. And I look forward to seeing you again on this same video conference Wednesday, May 31. Right? Yeah. Yes, May 31st. 31st of May, Wednesday, 4 o'clock. And with that, I'll see you guys. I'm pausing recording, not going away, but answering questions if you have any here, and stopping to record. Thank you.